Hello and welcome to another episode of React Roundup. I'm your host, Nader DAbit. Today on our panel, we have Justin Bennett.
Hey, everyone.
David Ceddia.
Hey, everybody.
And our special guest today is Aggelos Arvanitakis. Is that right? Did I say that close?
It's close enough. Hey there.
Hey, folks, I just want to let you know quickly about Netlify. Netlify is a really cool system for hosting what are traditionally known as static sites. However, the real benefit that I've been finding is that I don't have to mess with a back end. I can just set things up. I build the website out. I've been using a system called 11DJS, and you just deploy it. And then anything that you have that you want to do, you can do on the front end. So if you want to pull in some kind of database with Firebase or something else, if you want to collect form data, Netlify provides all kinds of services that make it easy to do all that stuff. If you're trying to do serverless, they have a really, really neat serverless setup that will allow you to deploy your websites without having to deploy a backend, and it'll do some of the work for you. I just love it. So if you're looking for a way that you can actually deploy a website that only has front-end technology in it, gives you all the tools that you typically need for the back end without having to actually program the back end, then give them a try. Go check them out at netlify.com.
Can you repeat your name for anyone listening that may want to get a better clarification of that?
Yeah, it's Aggelos, same way you'd say Angelo in Italian. And my surname is a tough one. It's called Arvanitakis.
Arvanitakis. Okay, cool. Yeah, well, welcome to the show. Today, we're going to be talking to you about optimizing for performance in React. And you do quite a bit of blogging, and you have, written some interesting articles and things like that. It looks like I follow you on Twitter as well, and you have, you're pretty active there as well. But before we kind of get into the topic, do you want to give everyone the introduction of who you are and what you do?
Yeah, so I started as a full stack developer 5 years ago, and for the past 3 years, I've been working as a front-end developer specializing in React. I'm working for an American company in Malibu. It's a music company named Orpheum, and I'm a lead front-end developer there doing React, but I'm working from our Greek office in Athens.
Oh, very cool. So you work in both Malibu and Athens?
Yeah, I tend to visit LA as much as I can, but I tend to work from here in Athens mainly.
Okay, cool. Those aren't bad places to work, right?
If it's the summer, you just say, oh gosh, I wish I could be on the islands. I wish I could be close to the beach. But being in Greece allows you to do small escapes every here and there. So during the weekends, I tend to take my laptop and just get off to an island and just work from there remotely.
So what do you specialize in at your job? Like, what are you doing most of the time? If someone kind of like walked in and looked at some of the code that you're writing, like, what are you doing most of the time?
So our company is a music company that has both B2C product and B2B products. And our B2B products, our clients are mainly big record labels and publishers. So we have internal tools that we use to help them and extra tools that we give them access to. Simultaneously, you will also have a public platform named orpheum.com, ORFIUM.com, that someone can visit. And if you're an artist, you can upload tracks, promote your music, monetize your music, and stuff like that. So I tend to be kind of in all of the products. So if you just came onto me, you'll be like in the office, you'd see me most likely writing React and either doing big code reviews for our front-end developers or actively contributing to one of these products. As I said, mainly using React and Redux.
Okay, cool. So that's interesting. So I guess what you're writing about are things that you've kind of learned on the job, actually doing some of the stuff in the real world. So topic being optimizing for performance in React. Let's kick off the conversation and maybe just talk about some of the most common things that we run into and things that people, the 80-20 of like what we can do to kind of like get our apps more performant before we can kind of go into some more in-depth stuff. So I guess, do you want to start off with any certain topic there?
Yeah, so most of my articles and my experience gets drawn from our B2C product, and mostly like I view every different product as a way of saying, hey, okay, I fucked that up on the previous product. I'm going to keep the good things that I did and move them to the next product. And then I'm going to try something new. And then I'm going to keep whatever worked for me and put it on the next product and so on. So my blog posts are a journey of the mistakes I've made and how I kind of resolve them on future products or even in the existing products. And one of them being performance. When we tend to want to say, okay, I want to learn React, we go to the React.js docs and we're like, oh, I'm going to follow that. We're also going to get a tutorial, Egghead, Udemy, whatever, and be like, I'm just going to follow that. And there are some things that you don't see and you don't understand when you're a beginner in React, but you do tend to understand and see as you advance more and become a better React developer. So one of the things that I saw was like, I tend to neglect the number of re-renders that React tend to do because I did not have a full understanding of how React worked back when I was just starting to work on React and starting to learn React. So I thought, okay, I'm going to gather most of the mistakes I've made, and I'm going to create blog posts on how like you can avoid common pitfalls and how you can, let's say, not do the same mistakes I did and also resolve them. So I don't know if you wanted to elaborate some more and be more explicit about this stuff or not.
I think it's interesting though that like this is a pretty common problem across the board. Is like React re-renders can tend to happen a lot and in places that surprise you that you don't expect. It's like, oh, well, I wouldn't think this whole thing would re-render. I think that like speaks to just like the tooling and ecosystem a little bit generally. I know there's like the React profiler, which the React team has done a lot of great work to make like much better. But, you know, one question as a community that we can ask ourselves is like, how do we lower that barrier of entry? How do we make it easier for people to understand like what the state of their performance is? I know that like where I work personally, we use React heavily, and we don't have a lot of people profiling React like on a day-to-day level. Like that doesn't happen very often. Generally, it only happens if there's a problem. And, you know, performance is one of these things that it's rarely a problem right up front. It's usually a problem like 3 months down the road, 5 months down the road.
Yep.
And everybody's like, why is this so slow? And by that point, it's like you need a big refactor to like really
it's too late.
fix it. So
I would say that in terms of React, like people, when I say performance in React, it sounds like a big spectrum, but it's actually really small. It only has to do with two things. A, the number of re-renders, and B, the time that each render takes. So you can analyze both of those using the React profiler, as you said. That's the first place you should go. And just because you cannot do that for every pull request that you get, you can also do lighthouse checks, which sometimes can and integrate them into your CI, where sometimes you can catch small stuff there. Or you can just, during your code review, make sure that the code that is written is actually optimized for performance. And in order to do that, you need pull requests that are like less than 200 lines of code, or perhaps it's too small, but in general, small pull requests that are fully reviewable. So you can spot these small things that accumulate over time. So if you wanted to elaborate some more on that, what I would say the most common problems are the fact that we get tutorials and we get sample code that is not optimized. So we copy and paste it, or we think that that's the norm. And if you're building a big production app, writing code the same way you see the sample code being written in one of my blog posts, or in general, one of another blog post or a tweet, is not ideal. So that's why I wrote an article on React performance, and I outlined the 6 most common pitfalls that you must do. And just to give you the TLDR version of those, is avoid any non-primitive things that you put in line. So avoid inline functions, avoid inline arrays, avoid inline objects, because they get a different reference on every render. So if you have a small component, that's okay. If you have just a single DOM element or a small button, you don't care about it re-rendering. It just takes 3 or 4 milliseconds. It's nothing. But if you have a big, heavy, expensive component that holds a lot of sub-components underneath it, then giving it a prop in line, which gets a different reference every time, can be catastrophic potentially for your app, depending on whether this expensive component re-renders a lot of the times. One other thing that people don't tend to understand that it's a problem, and I first saw it in one of Twitter's articles when they actually implemented Twitter Lite, was the fact that you don't always need to mount and unmount components, because sometimes this mounting and unmounting can take time, especially if you have a heavy component tree that reacts needs to call all of the lifecycle hooks on. So instead of hiding it and showing it through unmounting and remounting, what you can do is actually use CSS to do that. And the optimal way to do it would be to not even use display none, because display none and visibility do cause browser reflows, which essentially means that the browser recalculates all of the position and geometries of every DOM element on your page. So you can use opacity 0 or stuff like that if you can, which will ideally help the browser stress even less. Two other things would be memo-wise calculations, which means there's a new hook called use memo. So you can memo-wise expensive stuff, thus re-rendering the time that each render takes. And also it gives you the benefit of having referentially same props when, for example, you say array.filter. Array.filter creates a new reference every time. You don't want to create a new reference every time sometimes, so you can use a memoization technique. And lastly, kind of similar to images, React components don't need to be loaded if they're not needed. Same like lazy loading on images. If you don't need a component, you can delay its loading time, which will eventually create less stress to the main thread because the React runtime won't have to take care of calling the lifecycle hooks and integrating that to your DOM. So sorry if I elaborate too much there. I just wanted to give you
No, a lot of that stuff is really interesting, and I haven't heard of a couple of those actually, believe it or not. Especially the idea of some of the CSS stuff, and that actually makes a lot of sense. And kind of you going into some of the techniques and things around CSS would be interesting to kind of read more about. Where can we learn a little bit more about that? Does one of your posts cover some of the stuff in more detail?
I was actually planning to do a post on that and how you can use CSS techniques in React and that in order to
improve performance.
Yeah. Actually, yes.
That would make a flashy, good, interesting blog post title: "Increasing Performance in React with CSS."
Yeah, perhaps. Yeah, I was actually planning on doing that. But in the meantime, you can, of course, go to developers.google.com. There's a slash something. But on Google, there are a lot of articles analyzing what causes a reflow, which means that the browser recalculates a lot of styles. So if you go the non-unmount and mount way and you choose CSS, you can optimize that even further through these articles. But if you want to check whether you should use CSS and see what are the benefits, there's a post from the Twitter developers regarding Twitter Lite where they analyze what problems they had and how they fixed it and how they use techniques like that.
And use memo is similar to pure component, is that right?
Actually, memo, not use memo, is similar to pure component. Use memo is a way of saying, I'm going to memoize the last value that was created with these parameters, and only if these parameters change will I rerun this function in order to get a new value on something. So for example, if you have an array of users and you want to say, I want to filter the users that are active, you type users.filter where user is active. But if you do that on every render, then the array that gets outputted from the filter will have a new reference every time. So if you don't want it to have a new reference every time, but only want to have a new reference when the user's array changes, then you can use this hook and say, hey, only when the actual array changes will I need you to recompute that. So that helps a lot.
That's interesting. So use memo is part of the React library, but it's more of a JavaScript function versus it being part of React. I mean, of course, I guess it does, have to do, of course, with the React and the re-rendering and all of that. But okay, that's interesting. So what is memo then? Is memo? So I haven't used memo. That's kind of what I'm asking. Is that something that when you create a function, functional component that you use in some way there, or how does that work?
So if you have a class-based component, you can say class component extends react.component, and you'll have a React component. If instead of react.component, you say, I want it to extend pure component, then you have a component where it only re-renders when its props change. And when I say change, they change referentially. But just because you cannot do that with functions, because if you have a functional component, you don't have anything to extend from, you use memo. So you wrap your entire component with memo and it imitates the pure component behavior.
So could you dig into that a little more about how React will always re-render if it's not pure? Because I think that's one of the things that people, like beginners, misunderstand when they hear about virtual DOM and like React only, it does a diff and it only renders the things that changed. But they don't, maybe they don't sort of think that like the virtual DOM is where the diff is happening, but it's not at your component level, where React still has to call all those functions and run your render function, even though it may result in no actual DOM changes. It's still re-rendering.
Exactly. So a component will re-render when essentially its parent component re-renders. So if nothing above it re-renders, then this component will not re-render. But say you have a component hierarchy of 3 different components and the uppermost component renders, then the other 2 will be forced to render even though they don't need to. So essentially, you can say that if you don't need to re-render, don't re-render. But by default, in the way React is implemented, they will re-render. So you can say that either through this memo hook, you can say don't re-render unless your component, your props are referentially different, or you can also implement your custom logic saying that I want you to only re-render when this, and this changes. And you can do that through a lifecycle method called should_component_update, only available in classes. There's no hook equivalent up until now. And you can stop it from re-rendering. Now, what re-rendering means essentially is that each time you call the render function is called, it's the render method on class components and the whole of code that you put into a functional component if you have a functional component. What that translates to is that React is going to do all the calculations and create a big tree of the output, the thing that is going to be rendered to the screen. So it's going to say, okay, I created the output that I needed, and I describe it in a way that only me, React, can understand. And I'm going to compare it to what I had previously. And if these things are different, then that means that the DOM needs to be updated. So that's when it's going to be updated. But even if it doesn't, if they're the same and the DOM doesn't get updated, React still needed to create this tree in order to compare it to the previous tree. So that's what we call the reconciliation process. And that's how you can say, when you use pure component, you're essentially blocking this process from happening. So you're saying, React, hey, I'm pretty sure that just because the props didn't change, I don't want you to even try and compare the previous tree with the current tree of components. So I'll skip you the computational stress of doing that. So essentially, when you're rendering, you're essentially creating some internal structure that React understands that can say, am I the same with the previous render? And if I'm not the same, then I will change the DOM. So changing the DOM and essentially doing the reconciliation process are 2 different things.
Awesome. So like, why wouldn't you want to just make everything a pure component then?
Because of the time that sometimes it takes a lot of time. I would say a lot of time. I would say some time to do this checking. So if you have, let's say, the referential checking is the fastest. You just check if the variable A has the same reference as variable B. But if you have a component that has 10 or 20 or 30 props, and you have a total of 500 components, I actually created a Minesweeper React application, and I just cranked the cells up, and it was 10,000 cells, which were actually 10,000 React components. Imagine having to do this checking 10,000 times. So sometimes if you do it always, you're going to end up perhaps potentially hurting yourself more by doing these checks than if you didn't do them.
Yeah, that makes sense. It seems like you can also run into some strange problems where if you didn't want, so like the making something a pure component or using React memo will block the render from all child components. And sometimes you can end up in situations where like you didn't want to re-render the parent, but you did kind of want to re-render the child.
From my experience, that has happened a lot of times when I use the custom component should update method. Like I've said, when your ID changes, or when your title changes, then I want you to re-render. And I neglected something else that changed that didn't affect my component, but affected the component below that.
Yeah.
So as long as you use memo or pure component, from my experience, you're fully safe. But when you deviate from that and use custom should component update methods, that's when that will most certainly happen.
Seems like maybe it's safe to start from like the bottom and work your way up.
Yeah.
Don't re-render the leaf nodes if you can avoid it. And then
Exactly. Leaf nodes are most likely so quick to re-render that you shouldn't optimize them in any way. Optimize what is expensive And React is fast on its own, so don't try and optimize a div or a button. Just use inline functions, just use whatever you see in the tutorials, because it's okay. Just make sure not to do that on expensive components with a lot of computations and a lot of components underneath them.
So with the introduction of some of the newer React APIs, I know you already mentioned use memo, which is something you would use, with the newest version of React. How are the new APIs changing performance in React versus things that we may have done in the past? Or are there things other than use memo to keep in mind? And I'm kind of curious, if people can just start using functional components and hooks and just leave classes behind and still assume as good or better performance for their future applications.
So there was a kind of a myth that functional components in the past were a tiny bit quicker than class components. And it was partially true, but it was by such a small margin that it was negligible. Now, according to Dan Abramov, functional components are faster than class components. So in large-scale products, and when I say in large-scale projects, you should use them. But when I say faster, you won't see this speed in a small application. You'll see it if you're creating a big, huge production, large-scale app. That's when you'll be able to benefit by those fraction of a millisecond that each component's rendering time will be reduced to.
Something like Minesweeper.
Yeah. So essentially, functional components are definitely faster than class components, but you won't see any difference if you have a small to medium-sized application. Now, hooks, what they offer is give you access to a lot of the stuff that functional components didn't have in the past, which was state and I guess all the lifecycle hooks that class components used to have, apart from should component update. If you want to use a custom should component update, you'll have to use a class-based component. There is, if I'm not mistaken, now that I say it, there is a second argument in memo allowing you to specify how the diffing is going to be implemented. By default, it's a referential equality, but I think there's a second argument that allows you to somehow potentially replace the should component update with.
Yeah, I think you're right about that. I think you can implement a function that takes the props or something.
Mm-hmm. Essentially, there's no hook that you can use within your component, but if you use memo, you can potentially it will allow you to render your component with a custom function. But there's no use should component update hook. That's what I was referring to all the time. But apart from that, all the hooks out there are replacements, not replacements, but they give functional components the ability to use lifecycle hooks. For example, useEffect is implementing the component update. useState is actually allowing you to have a state in your functional component. So to answer your question, I don't think there's there's nothing extra that the hooks are adding. They're just giving you the API that the class-based components have within the functional component.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
So I'm guessing we can basically pick up hooks, leave classes alone, and as long as we're writing, the same logic, our apps should be as fast as before.
If not more, yeah.
Or if not more. Okay, cool. So is there any difference with use state and use reducer as far as managing state and performance that you know of?
In performance, no, but it does allow you to do smart things. For example, if you've used a state in a class-based component, and this state was an object that had 2 keys, one being username and the other one being password, If you type this dot set state, username something, then only the username would update and the password would stay the same. Now, there's you cannot actually do that on using hooks, because if you were to create a state using the useState hook that was an object that had 2 keys, you always have to update all the keys in the object each time you're updating the state. So this can become cumbersome. For like, imagine you having a state that was comprised of 10 keys. If you had a functional component that was using the useState hook, each time you wanted to update one piece of those, you would still need to write all the keys that the state would hold. So in order to avoid that, or in order to avoid splitting your 10 key state into 10 separate useState hooks, you tend to use a use reducer and a reducer function, which behaves exactly like the reducer function in Redux. In fact, you can take your existing reducer function in Redux and utilize it again, reuse it using the use reducer hook. And you can then have a better developing experience when it comes to updating your state. Essentially, it's going to be the same thing in terms of performance, but it's much easier to maintain and read.
Yeah, I've found out as I've started developing applications using hooks that if I have more than one piece of state that I want to keep up with in a component, I just use reducer, and I almost just default to use reducer at this point because it is so much easier to manage state, and it's a lot less messy. You have that one reducer outside of your component, and that way you're not using use state over and over and over.
Exactly. If you have more than one pieces, then you should use your user.
Yeah, and I've also run into some issues with use state, with using use effect and managing subscriptions and listeners and things like that. Have you run into any issues with that? This isn't really on the topic of performance, but I was doing some stuff with GraphQL subscriptions, and basically when the component loads, I set up a subscription in the use effect hook using use state. But for some reason, as the new data was coming into the subscription, the state was not being updated properly because of the scope of where the use state was initialized or something like that. Anyway, I opened an issue on the React repository. This was back in October of 2018. And I actually had someone from like the community chime in finally. And the solution was to use reducer because when you're dealing with listeners and subscriptions, for some reason, use state doesn't work.
I didn't know that. At all. One of the most of the things that I don't like about use effect is that I don't have a way to opt out from it running during mount time. Sometimes I want to be like, just don't do anything during mount time. But if something changes, then run this thing. And there's no like quick and easy way to say, I only want you to run stuff when stuff updates and not during mount time.
Interesting.
Yeah, for example, like I want to do something when, like I don't want to do anything when it mounts because you receive a prop. But if this prop gets updated, I want you to change something as well. And I came down to using like some sort of a Boolean flag saying, is this the first time you're rendering? Are you mounting right now? If yes, just skip it. If no, then
right.
Yeah, interesting. It's like if you want to just implement component did update without component did mount.
Exactly. Yeah.
Yeah. I guess you need one of those. You need a ref and you need to track the state and stuff.
Exactly. Yep.
Good case for a custom hook, I guess.
Yeah, and there's been a large community of those.
Yeah, speaking of hooks and Redux, it seems like they're moving in the direction of having some actual hooks now for getting access to Redux features.
Oh, don't get me started on that. I wrote an article on the initial alpha release. They were having 5 nice hooks, and then I received a tweet saying, use Redux, one of the hooks got deprecated. I was like, okay, I'm going to update my article. I'm going to add some more like thoughts and as to why this happened, what you can do, whether it was a good decision. Perfect. Like took me like half an hour. I was done. And yesterday I got emailed that, we changed the API again. And now we don't have this hook. We actually suggest that you use the dispatch method directly. And I was like, oh, come on. But I guess that's one of the bad things about like trying to write an article during an alpha release.
I guess that's the downside of alpha software. It changes a lot, but yeah. So what's the current API, or should we not even mention it because it's probably going to change again?
I don't know. Well, the current API it started off as being something like very big, and it just shrinked a lot. So you only have 3 hooks right now. Hopefully, I received a tweet from Mark Erickson, which is the core maintainer, saying that hopefully, fingers crossed, it's gonna stay as it is. So I think it's kind of safe to mention it. There are only 3 hooks now. Initially, there were 5, went down to 3. And you have a useSelector hook, which is essentially saying it's like a map state to props when you use the connect hawk. So essentially, you say that I take the state as an argument, and I want you to return me these values. And it's just like simple as this. The one thing is that you don't have access to own props. Own props is the second argument that the map state to props function would take, where apart from your state, you would also have access to the components props. In the hook, though, you don't have that. And if you want to have access to the props, you have to use custom use callback / use memo logic to make sure that the prop values you're reading are the latest ones. And this is the official suggestion. So if you're not reading the own props within your map state to props function, then you're good to go. If you do that, perhaps you're writing even more code than before. And you have to maintain that.
Oh, yeah, because otherwise the closure will capture it, and
exactly.
You get stale props.
In addition to that, funnily enough, the function itself is not memoized. Like you type like state, function state, return this. Like the map state to props is essentially a function. This function is not cached on its own by default. So you'll have to add a second argument to the useSelector hook, which is the first hook that I've been talking about, in order to say that I want you to either cache it permanently by providing an empty array as a list of dependencies, exactly like you type use callback, or say I only want you to update when this value updates, kind of like the use effect and the use callback. But normally that won't affect a lot of people. I'm just saying that if you expected this function to be referentially the same, it's not. So if you're reading just the state and you're reading it in perhaps in a custom hook or a small component, then you're fine. But if you want to use props and you want to have same referential mapping function, I guess, then you'd have some trouble because you'll need to implement some custom logic to do that. So that's the first function. The second one is a simple use store. It just exposes the store that Redux has, and you just get it back if you want to do anything with it. For example, it's good if you are using 2 stores for any reason within your applications. And when you're actually testing and you're not wrapping anything with a provider, you might need this hook in order to expose the store and do some custom stuff. And lastly, there's the use dispatch, which the use dispatch just exposes the dispatch function that Redux uses internally in order to dispatch actions to the Redux store. So funnily enough, although you might have been used to getting those actions creators through the connect as props to your component. So it would be like props.fireAction. Now with hooks, you import the action creators directly in your component, and you just call dispatched this, which is weird given the fact that the whole point of React Redux was not to expose this dispatch and do it kind of like behind the scenes. And now you're manually dispatching an action. And the downside to that is that when you're passing this as a prop to another component, you might type like an anonymous function or like an RF function that you'd say like parentheses, close parentheses, RF function, dispatch something. Imagine like an on-click listener. You type on-click, parentheses, RF function, dispatch something. And this, by default, as we said before, is an inline function and might cause performance issues down the line. So we'd have to use a use callback in order to make that have the same reference all the time, something which happened automatically before with the connect hook. So you lose a lot of stuff. You lose a lot of automatic performance optimization stuff that the connect hook used to have. And what you're getting is a way to read your state directly within your component through a hook.
So
Sounds a little
can you
bit like
still use, I guess, React Redux and connect in a functional component versus a class component, right? Like you don't have to use classes for React Redux in the old way without hooks.
Without hooks, you could use a connect hawk regardless of whether it's a functional component or a class-based component. Now with the hooks, you can only use it, of course, hooks can only be used in functional components. You cannot use them in class-based components. I would say that from what I read and from my analysis, the best way to use these new Redux hooks would be in your custom hook, in another custom hook, where you're like, I want to create a custom hook that does this thing, is reusable, and is also connected to Redux. And you could not use that. If you wanted to create a custom hook, it had to be completely unrelated to Redux because you had no way within a custom hook to read stuff from the state, where now you can. So that's a great upside to the release of these hooks. But other than that, I think in typical component, the connect is perhaps the best way to go with regards to performance.
So now that we're kind of on the topic of state management, a lot of things that I've seen in the community and a lot of like the thought leaders are kind of moving towards using context and doing away with Redux and MobX and all this stuff. What is your take on that as far as performance is concerned? And it's, it seems, of course, that since you're just using context directly versus using a library that uses context, the assumption would be that performance would be increased or improved. But of course, maybe libraries are taking into consideration some best practices that we might not know about or the average developer might not know about. What's your take on the current state of state management for as far as performance is concerned?
As far as performance concerned, I would say that, funnily enough, sometimes Redux or MobX or other state management libraries can be faster than using the native context API. I've read some articles that like React is a state management library. And personally, I kind of disagree to a certain degree, to the degree that of performance, because when you use the context API as a state, as a centralized state, let's say, when you update anything within it, all the other components that have subscribed to it through context dot, what is it? It's
consumer or use
consumer.
context.
Flex out. The context dot consumer will get updated regardless of whether they care about this piece of state that got updated or not. So if you're holding a lot of stuff in a single context, then updating one of this stuff will cause all your all your subscribed components to re-render, regardless of whether they cared about this change or not. And funnily enough, that was the reason that the Redux hooks were not released faster, because they were like, on version 6 of React Redux, we switched from each component subscribing individually to the store to have a common subscription using the context API. But the problem that they faced was that we could not bail out a component from rendering when a key that was unrelated to this component updated. So essentially, we could not stop a component from rendering when this component did not need to re-render. So with regards to performance, I would say that Redux is smarter than the context API. And it tried it. React Redux tried using the context API and said, no, we'll have to switch to individual subscriptions again. And each component, instead of having the whole state in the context API, we'll have to break it down.
So it looks like we're kind of getting close to being there on time as far as what we have for the show. Is there anything that you wanted to cover that we haven't really discussed that you think might be helpful to the listeners?
I would say there are a couple of techniques that when you're using Redux, you can benefit in performance. One would be to use selectors. Never try and say, I'm going to read directly from the state, because if you're then doing some sort of filtering or a find operation in an array, you'll still get different references every time you run it. So use selectors, please, and Redux. You can read more about in the official Redux documentation, I guess, like page. The same thing is make sure you're using referentially the same action creators. So this is a big topic. You can read about it in one of my blog posts, but essentially make sure that the things that get passed as props that get fired and update the state are always referentially the same, because you can achieve that. And the latter would be to, if you have a lot of different actions that you fire one after the other and they are unrelated, and when I say unrelated, I mean they affect a different state slice, and which would translate to you can rearrange those dispatches and nothing would change in terms of the outcome. Then you can batch them together. So React Redux 7.xx has a new batch method. Then you can say, I want to batch these 3 actions together. So instead of firing 3 actions, which would result in 3 different re-renders, you can just say batch action 1, action 2, and action 3, and we would only get 1 re-render. So with regards to performance, that's what I had to say.
With the selectors, that's basically a reselect, right?
Yeah, in general, it's a selector. Like reselect is a special implementation of the selector. Selector is any function that returns the state slice, and your component that says, I'm going to just pass the state to this selector, and I am sure that this selector will return to me the state that I want without me, the component, knowing what this selector does. So, but essentially, reselect is actually a performance optimization on top of the typical selector, which actually does what essentially use memo does. But just because you cannot use memo outside the React ecosystem, I guess, like outside the React component, you use reselect to do that.
Okay, yeah, and I was going to also mention use memo, because it sounds like basically, that's kind of what's going on. Memoization is happening, right? And,
exactly.
And reselect, yeah.
This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/react. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
Okay, cool. So I think we'll go ahead and get to the picks, and I guess I'll start with David. Do you have any picks?
Let's see. So, well, it's not super React related, but I guess it's kind of front end related. Last week or a couple weeks ago, Svelte 3 was released, and it's just an interesting new-ish UI framework. I guess Svelte has been around a little while, but Svelte 3 is kind of a new take on it. And they just have some really interesting ideas. And if you're interested in just checking out new happenings in the front end world, check out Svelte.
I keep hearing Svelte. I'll have to check it out.
It's pretty cool.
Justin, do you have any picks?
That was actually going to be one of mine. Yeah, I've been working on a PR for Svelte recently, and digging into the project's pretty interesting. So I do have a React-related pick. So several episodes, I picked this library called Ink, which is a way to build CLI apps with React. So it's like a way to render or to write, CLI commands with React components. So the author of that library just released a framework called Pastel. So Pastel is like Next.js for the CLI. So you can build a CLI command just like based on like a file structure, and it does some really interesting things, like uses prop types to define arguments for your CLI function. It's really, really awesome, and I'm super excited about it. There's one other thing. So I've been doing a lot of research into end-to-end testing recently. I've actually got a history in this, so it's a really interesting topic for me. There's two tools on the market today that like do a really great job of that. I think one of the more popular ones that probably most people have heard of is Cypress. So Cypress is like built on Chrome, but it's like a way to like visually create tests, and it's like it's an awesome sort of abstraction. The other tool that I feel like maybe not as many people have heard of is Test Cafe. So Test Cafe takes a little bit of a different approach than Cypress. So it actually like runs this sort of like proxy server so you like write your tests in Node, and it like proxies like the appropriate commands to like any sort of browser. So it's not like a Selenium based testing infrastructure. Neither Cypress nor Test Cafe use Selenium based, but Cypress is very Chrome specific, and Test Cafe will work with most every browser. So if you're looking into end-to-end tests, I would advise you to research both of those. So they're both good for like different problem areas. But yeah, check those out. That's all for me today.
Aggelos, do you have any picks?
I have a library that I've been waiting to get into to a stable release for quite some time. It's called VX, 2 letters, VX. It's from Harrison Schaaf that works in Airbnb. And it's a React library that couples React and D3. So whenever you want to create custom charts for your company, so a library of custom reusable charts for a company, it exposes nice primitives that you can reuse in order to compose your own charting library. So that's cool. And the other one is kind of fully unrelated to everything. It's fully unrelated to React for sure. It's a nice blog that I've seen about architecture, infrastructure, deployment, automation, CI, data, security, which is from Riot Games. Riot is a company that does League of Legends, a popular RPG game. And they have a blog that describe how are they architecting all that? How are they handling security, infrastructure, performance? It's really interesting. Every blog post, it's superb. And you can find it at technology.riotgames.com. So that's the 2 picks of mine.
All right. So I have a couple of picks. The first is going to be React Native and like the reemergence of what I'm seeing the React Native team do over the last year. We had Christoph Nakazawa on our podcast, React Native Radio. If you want to hear more about what's going on, check out that episode. Also, check out Eli White on Twitter. He just went on a Twitter rant yesterday, kind of, or like a long thread, going over a lot of the stuff going on and a lot of the investments in React Native. And he gave a talk around basically what to expect in the future from React Native. And it's pretty exciting to see, how many applications are being used in React Native and actual performance differences between Native and React Native, which is what really people are always interested in, and information about the re-architecture and the improvements made in the re-architecture. So React Native is one of my picks. And then my second pick is a tutorial that I released today called the Complete Guide to User Authentication with the Amplify Framework. And it goes through how to add OAuth with Facebook and Google and Amazon, but also how to add username and passwords authentication. And then also how to combine, all of those together for, most modern applications typically have multiple authentication types. So like how to actually do that. And then next week, I'm going to be releasing a post for this with React Native. So the post that I released today is with web. The one next week will be with React Native. So if you're interested in that, check that out. So I think that wraps up this episode. Aggelos, it's been a pleasure having you on. I learned a lot. It sounds like you know more about performance than maybe anyone I've talked to so far. So it's pretty cool to hear all of the ideas that you have. I need to read through some of your blog posts.
Thank you so much for the kind words. It means a lot coming from you.
All right, that wraps up this episode of React Roundup. Thanks for listening, and we'll see you next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.